Welcome to another Science News Update. Hey there, Braves, and welcome to your first Science News Update. Scientists have recently discovered that our solar system is currently traveling through, and has been traveling through, a debris field of an ancient dead star, one that went supernova as far back as 3.5 million years or so. How do scientists know this? What does this mean for us? Well, normally when astronomers are looking at stars far away, they do comparisons of similar stars. Stars of the same size and mass should be about the same brightness, and anytime we find one that's about the same distance away, same size, same mass, but is dimmer than others, we generally infer that there's dust and debris between us and that star, making it appear dimmer. Kind of like how hard it is to see the car in front of you on a really dense, foggy morning. The more particles of water floating in the air between you and that car, the harder it is to see it, and that's why you rear end it when you're looking at your phone, and, well, we won't go there. Point is, what scientists have been noticing after taking very careful measurements of all of the surrounding stars is there is a bubble in this dust and debris that we should normally be getting around our solar system. And this bubble actually has less dust and debris than is normal. It was hypothesized that maybe a shock wave by a supernova cleared the area out for us. And after making several very careful observations and making note of the overall direction and speed of travel by all the surrounding stars, scientists have even been able to recreate where they believe this supernova took place. This supernova took place supposedly in the Scorpius-Centaurus OB association. It's a cluster of stars. And what scientists have been able to do with supercomputers is rewind the tape to see where about this particular supernova occurred. Now, here's the interesting part. I told you that we're currently going through a debris field, so you wouldn't expect us to have less debris if that were the case. So here's the deal. The shock wave basically thinned out the dust and debris for us. That's what we're traveling through now. But every so often, we will float through, travel through, remnants of this particular dead star. And those remnants are basically iron-60. Iron-60 is a radioactive version of iron that is only created in a supernova. So how do we know we're getting all of this iron-60 here on Earth and, using that as proof of this particular supernova, this past supernova? Well, here is what's really interesting. Not only have we been able to look back in the ice sheets, which they don't go back millions of years, just, thousands. But within the last 20 years, we've been able to identify some iron-60 in some of the ice sheets. Now, it's not continuous. So we go through bits and pieces of this dead star every so often. But here's what's really, really cool. Some scientists, I'm going to assume geologists or stratigraphers, because they're the people who look at the layers of sediment of Earth and rock layers and all of that, have identified layers of bacteria, fossilized bacteria, that used to incorporate this iron-60 into their bodies. And finding this iron-60 inside of these particular bacterial fossils, well, this dates back as far as 3.3 million years. Now, the problem with iron-60 is it doesn't last very long. Being radioactive, it breaks down, and it doesn't last much longer than 3.3 million years. However, the really cool part is why those bacteria are incorporating that iron into them to begin with. So, we use this iron-60 in the bacteria to prove that, the overall date of this particular explosion of the star, all that stuff. But why are they doing that? Well, these magnetotactic bacteria use iron to create little tiny magnetic compasses inside of their body. Yes, tiny bacteria that don't have brains, don't have fingers, or any of the things that we would need to make a compass ourselves. They actually take in iron, create microcrystals inside of their body, and they make them in a nice line inside of their body. And they use Earth's magnetic field and these crystals to help them navigate in the waters of the ocean. Mind blown, right? The interesting thing about these bacteria is that they do this all the time. And when we look at the layers of sediment with these dead little critters in there, you will see a layering effect. So sometimes when we're traveling through this debris, we will pick up iron-60 in our oceans, and the little critters will use it, and then they die and they float to the bottom of the ocean. But when we're not flying through it and we're not accumulating iron-60, those little critters are still taking an iron, just not that particular type. And we can actually track when, down to, within a few thousand years, when we've been traveling through this debris field and when we haven't. So this is astronomy working with biology, working with geology and stratigraphy. And this is one of those reasons why I always say it's best not to specialize too much and to be aware of broader scientific field of study so that you can kind of connect your study to what's going on elsewhere. And now we have a big, wide view and understanding of a particular topic. So tiny bacteria used freshly made supernova material to create compasses inside of their bodies to help them navigate using Earth's magnetic field. And we use that information to identify when a supernova, millions of light years away, blew up. If that's not mind-blowing, I honestly don't know what to tell you. And that's it for your first Science News Update. I'm your teacher, Chris Clemens. I'll catch you later.